Okay, so here we are at another case study, Towers of Hanoi. The Tower of Hanoi problem is a classic problem that can be solved easily using recursion, but it's difficult to solve otherwise. The problem involves moving a specified number of disks of distinct sizes from one tower to another while observing the following rules. There are n disks labeled 1, 2, 3, and 3 towers labeled A, B, and C. No disk can be on top of a smaller disk at any time. All the disks are initially placed on Tower A. Only one disk can be moved at a time, and it must be the smallest disk on the tower. The objective of the problem is to move all the disks from A to B with the assistance of C. For example, if you have 3 disks, the steps to move all of the disks from A to B are shown in the figure below. So we can start this animation. Okay, so A to B, okay, so in the case of the 3 disks, you can find the solution manually for a larger number of disks, even 4. The problem is quite complex. Fortunately, the problem has an inherently recursive nature, which leads to a straightforward recursive solution. So the base case of the problem is when n equals 1 and n equals 1. Right. So if you could simply move the disk from A to B when n is greater than 1, you could split the original problem into the following 3-step problems and solve them sequentially. Move the first n-1 disk from A to C recursively with the assistance of Tower B. So we have n-1 disks, move n from A to B, so n-1 disks get moved from A to B, and then step 1, move the n-1 disk from A to C recursively. Okay, so we're skipping the steps here, so it goes 0, 1, 2, 3. So we're taking these disks, and then we're moving it over here, and then we're moving it over here, and then finally to B. So move disk n from A to B, as shown in step 2. Move n-1 disk from C to B recursively with the assistance of Tower A, as shown. The following method moves n disks from tower to tower with the assistance of the auxiliary tower. So you have the method move disks, which takes in the number of disks, and then the from tower, the to tower, and the auxiliary tower. The algorithm can be described as follows. If n equals 1, move disk 1 from the from tower to the to tower. Otherwise, recursively call move disk n-1 from tower to auxiliary tower to tower, and then move disk n from the from tower to the to tower, and then move disk n-1 to the auxiliary tower to to tower from tower. So here we have an example. Here we have the Tower of Hanoi, public static void main. So we're bringing our input in here. We're entering the total number of disks is 3, and then we have our scanner input here, which captures that, and then we move the disk n. Then we have our basis for the disk A, B, C. So the method for finding the solution to move n disks from tower to to tower with the auxiliary tower. If n equals 1, that's our stopping condition. Okay. Otherwise, move disk n-1. This comes from the explanation right here, right? Move disk n-1. This is our condition. So automatic check, your code is correct. And that's how we can move the disk from one tower to the other tower. This is just a recursive function that goes through and recurs on itself.